You are holding a pen. Somewhere inside it, resting in a thin plastic tube, is a dark liquid you have never once stopped to think about. You have used it thousands of times. You have never asked where it came from. Here is the short version. That liquid took 3 separate civilizations, working on 3 separate continents, to invent, and none of them knew the others were doing it. One of the recipes they landed on is so good at its job that it is still, right now, slowly eating through the pages it was written on. That story does not start anywhere near a pen. It starts with a piece of wet clay. For most of human history, if you wanted to leave a mark that lasted, you carved it. A scribe pressed a cut reed into a soft clay tablet, and once that tablet baked hard in the sun, the mark was permanent. Stone worked the same way. Both held a shape forever. Neither one traveled. You could not roll a clay tablet into a scroll, fold it into a letter, or carry it up a mountain in your coat. And the moment people needed to write on something soft, a strip of animal skin, a length of cloth, a sheet of pressed reed, pulp, clay, and stone were useless. A merchant sending word ahead of a caravan could not mail a slab of baked mud. You needed a mark that could sit on top of a soft surface, dry there, and still be legible 1,000 years later. That thing did not exist yet. Someone had to invent it, and it turns out someone had to invent it 3 separate times, in 3 different kitchens, out of whatever happened to be lying around. Here is where it gets strange. You would assume a discovery this important came from one flash of genius, in one place, at one moment. It did not, and it did not even start as a recipe for ink. In the 1st century AD, the Roman writer Pliny the Elder described a simple chemical reaction. Mix an iron salt with a tannin-rich liquid, the kind you get from soaking oak bark or crushed plant galls, and within seconds it darkens into a deep black-blue stain. Pliny wasn't describing ink. He was describing a way to test whether a piece of vellum had been secretly bleached and reused to hide a forgery. One strange trick among hundreds in a book that cataloged the whole natural world. Nobody had turned that exact reaction into a writing ink yet. The real question worth asking is not how ink was invented. It's how a fraud detection trick, sitting in a book anyone literate could read, took a full century, maybe 2, before someone finally thought to write with it instead of just testing with it. The answer is that nobody needed it yet because 3 other groups of people on 3 different continents had already solved the leave a permanent mark problem their own way with whatever raw materials they had on hand. In Egypt, scribes were writing on papyrus with a black ink made mostly of soot. In 2017, researchers at the University of Copenhagen ran X-ray microscopy on 2,000-year-old papyri private letters belonging to a soldier named Horus, stationed at a military camp, and documents pulled from the Tebtunis Temple archive. They found something nobody had expected to find. The ink contained copper, not deliberately added a byproduct, left over from the process of extracting copper out of raw ore and never filtered out. Egyptian scribes had been writing with a metal for centuries without knowing it, riding along in the leftover dust of an entirely different industry. In China, at almost the same broad stretch of history, a completely different solution was taking shape. The earliest confirmed Chinese ink is a pine soot stick from the late Warring States period. More than 2,000 years ago, soot collected from burning pine branches in a restricted supply of air, then bound into a solid. Archaeologists later opened royal tombs from the Han Dynasty and found ink pellets still intact inside, pressed from pine, soot, and animal glue, ready to be ground with water the moment someone needed to write. 2 kitchens down. The 3rd one wasn't a kitchen at all, it was a cave. And in the dry caves above the Dead Sea, the scribes who copied the scrolls that would sit hidden for 2,000 years used a 3rd recipe entirely carbon soot again, but bound this time with gum arabic, a sap pulled from acacia trees. Scientists only confirmed that specific binder in recent years, using an extraction technique gentle enough to lift proteins directly off the parchment without damaging the fragile scroll underneath. 3 regions, 3 unrelated recipes. Accidental copper in Egyptian soot, soot and animal glue in China, soot and tree sap by the Dead Sea. None of these traditions knew the others existed, and that gap you were promised at the start? This is why it didn't matter yet. All 3 groups were already chasing the exact same target, something dark enough to read and sticky enough to survive, and all 3 had already found a working version of it. Pliny's fraud detection trick had nothing urgent left to solve. Not yet. So if 3 working versions already existed, why did anyone eventually bother inventing a 4th? Because all 3 of the early inks shared the exact same weakness. Carbon ink sits on top of a page. It never bonds with the surface underneath it, which means it can be washed off or carefully scraped away and quietly rewritten. That is barely a problem for a poem or a shopping list. It becomes a very serious problem the moment ink starts recording contracts, wills, land deeds, and legal testimony documents where someone, somewhere, has a real financial reason to make an inconvenient line disappear. That is the exact gap Pliny's fraud detection trick eventually filled. In a collection of magical and technical recipes written in Egypt sometime in the 2nd or 3rd century, a document scholars today call the Leiden Papyrus, someone finally wrote the reaction down as an actual writing. Formula: an iron salt, crushed oak galls, and gum arabic, combined on purpose, for the first time on record. It did something none of the 3 carbon inks could do. It did not sit on top of the page. It reacted chemically with the fibers underneath it and bonded directly into them. Try to scrape it off, and you tear the page apart trying. For the first time in the whole history of writing, a document could actually be trusted not to change after it was signed. Word of the recipe spread slowly, the way most things spread before printing existed, copied by hand, workshop to workshop, monastery to monastery, across the collapsing edges of the old Roman world. Within a few centuries, monks bent over writing desks in scriptoria from Ireland to Constantinople were mixing their own batches from crushed galls and rusted iron nails because the ingredients were cheap, local, and nearly impossible to run out of. The reaction that had once sat in a book about catching forgers became the default writing ink. People stopped calling it iron gall ink at all. They just called it ink, as if nothing else had ever existed. Here's who ended up using it. That single property, the one no carbon ink ever had, is why iron gall ink became, for the next 1,000 years and more, the standard writing ink of an entire continent. Leonardo da Vinci filled his notebooks with it. Johann Sebastian Bach wrote his manuscript scores in it, note by note, measure by measure. Rembrandt and Van Gogh drew with it. Early drafts of the United States Constitution were written in it. Every one of those documents survives today, in some measurable part, because someone, somewhere in Roman Egypt, finally wrote down a reaction. Pliny had only ever used to catch a liar. But here is the part that stays with you once you actually know it. The exact quality that made iron gall ink impossible to forge is the same quality that is, right now, quietly destroying it. That bond, the one that bites into the fibers of the page instead of sitting harmlessly on top of them, does not stop reacting once the ink dries. Given enough centuries, it keeps eating, slowly, into the very paper it was trusted to protect. Archivists even have a name for the damage: iron gall corrosion. You can see it in old manuscripts today as tiny, ragged holes, appearing exactly where the ink itself once sat densest, the signature eating the page it signed. That same slow chemical change is still studied today, just for a different reason. As iron gall ink ages, the balance between 2 different forms of iron inside it shifts in a slow, measurable way. Measurable enough that conservators and heritage scientists now use it to predict which centuries-old manuscripts are closest to serious damage and which ones can safely wait their turn. The reaction Pliny once used to catch a liar is now used to catch a page before it destroys itself. The ink built to outlast every forger who ever tried to alter it is, letter by letter, erasing itself anyway. Nobody designed it to do that. Nobody, writing down a formula in Roman Egypt to catch a fraud, could have known that permanence and slow self-destruction would turn out to be the same chemical reaction, just viewed across a longer stretch of time. So, the next time you pick up a pen, you are holding the 4th attempt at a problem 3 earlier civilizations had already half solved without knowing it, and without knowing each other. Accidental copper in Egypt, pine soot in China, tree sap by the Dead Sea. And somewhere in Roman Egypt, a century or 2 after Pliny wrote down a trick for catching liars, someone finally read it and realized, this isn't just for catching forgeries, this can write.